Right? Next, we're going to talk about yet another tectonic impact of the Cenozoic. Moving on over to our west coast. Most of the spectacular landscapes that we know in Western North America were formed during the Cenozoic. Right? So if you've ever been in a plane flying cross country and you look out your window and you see these gorgeous linear mountains, right, kind of look like wrinkles on the surface of the earth. Maybe you actually stop, go to the ground, and are able to look up at these mountains. Definitely not as big as the Himalayas or the Alps, right? But pretty impressive mountains, still the same. What you're looking at here, these mountains that kind of look like wrinkles on Earth's surface out west, are called the Basin and Range Province. Covers almost the entirety of Utah and the states around it. Or sorry, not Utah, Nevada. Covers the vast majority of Nevada and the states around it, including Utah. So the Basin Range Province formed in Western North America. It's a large area of alternating basins, meaning low valleys, and high mountain ranges, hence the name Basin and Range. The province extends across a wide region all the way from Nevada and Western Utah southward into central Mexico. Now, the way this region was formed was during the Mesozoic era, when we had the Pacific plate colliding with the North American plate. The entire region was pushed up because of those convergent tectonics, pushed up and warped upwards, arched upwards. Then, beginning during the Miocene and the modern Cenozoic, that arch started to subside, right? It started to fall back down, and that formed a lot of normal faults that were parallel to each other, right? These uplifted blocks stayed as mountains, and the blocks that fell down along those normal faults then became the basins, the valleys, and they were also filled with the sediment that was eroding off of the mountains. Right? So faulting opened up fissures for the escape of molten rock and magmatic bodies below. So not only did we get this welling up of the surface because of convergence, and then eventually settling back down, creating these normal faults, those faults also allowed for a lot of lava to escape up to the surface and a lot of volcanism in this area. So there was a vigorous erosion of the uplifted fault blocks following the volcanism. Coarse sediment eroded from the mountains, cascaded down those mountains, down rivers, clogged those rivers, caused lakes to develop behind those debris dams. There was a lot of evaporation that also happened. We know how hot and dry it is out there, so a lot of gypsum and rock salt were created in these lakes. So if you've ever fly out west and you notice these mountains that are all linear to each other, they kind of look like wrinkles. Remember, it was the convergence pushing those landscapes up. Then they kind of deflated, they sunk back down, creating faults and wrinkles and volcanism. Right, so that's the Basin and Range Province. But this isn't the only landscape out west. You might be thinking to yourself, well, this doesn't sound at all like the Grand Canyon, right? This doesn't sound at all like those vast flat areas out west, right? So something different created those. So let's talk about the Colorado Plateau. The Grand Canyon, which is shown in this picture here, is actually carving down into the Colorado Plateau, which has that flat top. The Colorado Plateau is a vast and magnificent region of uplift. The plateau was repeatedly raised during the early to middle Pliocene, so about 10 to 5 million years ago. And as it was raised higher and higher and higher, right, uplifted higher and higher and higher, the Colorado River eroded down deeper and deeper and deeper into it, and eroded 2,600 meters down. That's 2.6 kilometers down, not several miles, but multiple miles down into the Colorado Plateau, creating the Grand Canyon. And this took 6 million years. So over the past 6 million years, erosion rates were about 23 centimeters every 1,000 years, which sounds very slow, right? But when you have millions of years to erode, you can create something as large and spectacular as the Grand Canyon. So erosion rates proceed more slowly today, but there's still a lot of erosion and water still removing sediment from the Colorado River. One of the reasons erosion is proceeding slower today is because humans have used a lot of that water for irrigation purposes, for drinking purposes, for industry. So a lot of the water that used to run down the Colorado River is gone. We've taken it out. which means there's not enough erosion power to continue on that same erosion rate as before. Fun fact, so the Colorado River, it's a huge river, right? It's huge enough to carve out the Grand Canyon. But because so many humans are extracting water from it, by the time the Colorado River reaches the Sea of Cortez down in Mexico, where it discharges into that sea, some years there's no water left. It's just a dry riverbed by the time it gets down there because humans have used all of the water within that river.